All right, so what team am I talking to?
You are talking to the Iradion Laser Simulation Optimization Project team.
That is a mouthful. I might stick with Lassimo or Lacimo. Now, what's your guys' names?
I'm Jonathan Fasano.
I am Bennett Lalo.
And are you both computer engineers?
One computer, one electrical.
Okay,
Yeah, electrical.
Awesome. Now, your project, I heard laser somewhere in there. Can somebody please give me a brief description in a couple sentences?
We are trying to mathematically model a laser cavity in MATLAB. We're trying to replicate laser output for the company to use when it comes to modeling their actual lasers before they make changes and build them.
Now, is that not something they've done before, or?
Essentially, this is an unstable resonator,
Okay.
which means there's no actual closed solution.
Hmm.
So no, this is not something that can be modeled with just a quick formula.
Wow.
Which is the stable resonator. That's how you model those.
Mhm.
So this needs actual iterations through the cavity, full simulation.
So this could be some groundbreaking work you guys are doing.
Hey, we think so.
How does it feel, working on the project, working with the company?
Feels pretty neat, actually.
What do you guys think is your favorite part? Is there anything specifically, challenging you've overcome, or if there's just, a specific aspect that you find, particularly cool or enjoyable?
Really, one of the more interesting things is just getting to see all the different waveform outputs as mesh graphs, because there are some really interesting things that can happen when the light simulation happens, and you can get these really interesting looking graphs out of it.
Yeah, I guess it's not quite like a laser pointer for a cat. We're talking some big heat here, some big lasers.
Yep, and even for small lasers too, though, which is not as expected. But like he said, it's just interesting because we see light all the time. But to actually model it and understand what's happening with these very clear visuals, it just adds another dimension sort of for that understanding.
That's awesome. So right now we're in the fall symposium. You guys obviously scored very well, second place. Congratulations. Moving on to the spring, what's left to do?
Predominantly, the model that we have is up to what we would say is passable. We're going to compare it to the actual laser output and try to fine tune it from there.
Perfect. You guys have a fair amount of confidence in getting that done. Think we're going to smash it out of the park?
I think so, yeah.
We believe so. The only parameter there is that we are testing against an actual laser, so we have to build this pretty extensive portfolio of the output from that beam. So there will be some time, but we are confident that we can finish on time.
Well,
Yes.
Confidence is key. Now, working with a company, how is it different than working with professors? Do you find it better, worse, just kind of different?
It's definitely different, for sure, but it's got its ups and downs like anything. It was nice to work in a professional setting and be treated like a professional, and in that same way you're expected to produce deliverables. And so I thought that was a good kind of transition to industry.
Yeah.
Definitely a good learning curve.
I mean, you guys are seniors. You're almost done.
Yep.
Yeah.
Awesome. Well, in that case, I just kind of really have one more question. Kind of ask all the teams. If you're back freshman year, if you see an incoming freshman who might be looking towards engineering, you think you're likely to recommend them towards the ELECOMP Capstone program?
I think so, yeah.
100%.
100%? Perfect. Well, let's see if you guys can take that top spot next spring.
We look forward to doing that.
Perfect.